Okay, we should be live, so you can go ahead.
Great stuff. Thanks, Kendall. Hi, everybody. So my name is James Butcher, and welcome to the fourth in our series of EdgeX Tech Talks for this year, 2022's EdgeX Tech Talk series. This one is about building a device profile and the instructions for doing that. That is creating the configurations that describe your edge devices and getting them onboarded to the platform, as well as I'll show some tooling and some live demonstrations. We'll just wait a couple of moments maybe for everybody to sign in, and then we'll get started. While we're waiting, by the way, please be aware that today's presentation, after we've finished, will be available, and associated resources and the video recording will be available at the link shown on the screen. And that also includes previous talks held by Jim White and Lenny Goodell, and they're also there as good EdgeX resources for people to watch. So once again, we'll get started in just a couple of seconds. Thank you. Okay, everybody, let's get started then. So I think the first thing I need to do is to properly introduce myself. As I said, my name is James Butcher, and I am a product manager at iTech Systems. And iTech is a global B2B edge software products company. I'm based in the city of Newcastle in England, and I manage our EdgeXpert product. EdgeXpert is based on the EdgeX Foundry. I'm sure I'll talk more about that later. I've been with iTech for around 4 years now, and one of my previous roles was to be the solutions architect. And I was working with a lot of customers closely, helping them use the EdgeX-related tech. And I'm pretty dedicated to product usability, so ease of use of the platforms. So I'm sure that'll come out in some of these talks where I particularly talk about the tooling. And I'm also heavily involved at the EdgeX Foundry. So in fact, just yesterday, I was announced as the TSC chair for now and onwards, and really looking forward to doing that. I've got quite a long history with EdgeX already, so I've previously ran the testing QA working group and also the core working group. And like I say, really looking forward to leading the EdgeX group and seeing the great innovations we can continue to bring. So, next slide. There we go. So, this is a reminder that this is the fourth talk in our Tech Talk series throughout May and June. We've already covered getting started with EdgeX, building an application service, building a device service. This one, as I said, is about building a device profile, helping to get your devices onboarded to the platform via configuration, so not needing to write any code. And then next week, Canonical are going to be running a session about getting started with EdgeX and snaps. So please do join us for that one as well. So today's agenda is we're going to cover what is an EdgeX device service. We need to remind ourselves about that from last week. And then we'll jump straight into the device profiles. So there's three main aspects to a device profile: device information, device resources, and device commands. I'm also going to be talking about creating a specific device profile. Now I'm going to use a Modbus power meter as an example. I'll show how to do that and how to onboard a device using EdgeX. And then I'm going to show some tooling to make things even easier, in particular the device configuration tool provided by iTech, and showing that with the Modbus example. I'll also touch on the EdgeX Ready program and how device profiles can be verified. And then we'll finish with resources for further assistance and commercial device support from the EdgeX ecosystem. And then also time for Q&A at the end. So please don't hesitate, by the way, to add questions into the QA or chat windows as we're running. I'm happy to stop and answer those as we go. So, as I said, a quick reminder about device services. So this is the general platform diagram of EdgeX, and we're going to be focused today at the south side. So the device services are the interfaces between the southbound, your OT devices, sensors, cameras, and control systems. And the job of these services is to get the data from these real devices and make it available to the wider EdgeX services. So a little bit more detail. An EdgeX device service then connects the rest of EdgeX with a device or sensor. Now, these are usually physical sensors or things that we speak about in the IoT. And they could be vibration sensors, thermostats, cameras, moisture sensors. There are any number of sensors on the market and edge devices on the market these days. But they could also be a virtual sensor. So, for example, it could be an application that retrieves a forecast from the internet about the weather, for example. So that information can also be collected by the platform and fed into the system. Now, device service speaks a particular protocol because it interfaces with the physical device. Example protocols are things like Modbus, BACnet, GPIO, and so on. We'll talk more about those in a second. So the roles of a device service are basically two primary roles that a service has. And the first is to get or collect the sensor data from a particular device. So it could be the temperature or the humidity, perhaps, from a thermostat. And another role, some devices have the capability to set or actuate. So EdgeX can also do that. The device services can do that. So, for example, on a thermostat, you might have a set point for where the temperature should be changed. So a cooling point or a heating point. Users can configure those, and EdgeX device services can write to those as well. Now, device services have other jobs too. And a pretty key and fundamental aspect here is the ability to transform the sensor data into EdgeX formatted messages. So we call that normalizing the data. And that's really important because it allows EdgeX to be able to treat the data the same, whether it was from a Modbus device or a BACnet device or an MQTT device, for example. So that's a really important aspect of the device services. And they can also do a bit of housekeeping, so they can monitor the device or sensor. Is the device still connected? Is it functioning? Is it still online? Is there any other metadata that we need to be made aware of about how the device is operating? And some of the more advanced device services can also support automatic discovery. We call that provisioning, and that is protocol dependent, and I'll talk more about that later as well. The existing device services, so the EdgeX Foundry provides a number of existing services for popular IoT and OT protocols. So as I said, Modbus, BACnet, SNMP, a whole list there. Also recently, we've added support for cameras, so be able to control cameras and get video streams from cameras. So OnVIF and USB cameras, part of EdgeX as well. Now, these device services are usually written in Go or C. We have device service SDKs for both languages, but actually, for most users, the language doesn't matter because you're typically not coding yourself, you're configuring these device services. And that's really the main subject of today's talk, how to configure the device services to get the data onboarded in the easiest way possible. And we do this, like I said, via a low or in fact no code approach, which really helps save integration effort and time. Now, EdgeX also comes with a virtual device, which is basically a simulation that lets you model different device sources. So we have feeds for integer values, Boolean values, float values, and so on. So that's really easy to use as well. And also, there are third-party providers in the EdgeX ecosystem, such as iTech, my company. And one of our roles is to provide additional device services, commercial device services. So we offer more complete protocol implementations of some of the standard ones like Modbus and BACnet, but also proprietary protocols, particularly interfacing with things like Siemens, PLCs and Profinet, these are commercial licensed stacks. So it will be kind of against the open source model to be incorporating these commercial stacks into the EdgeX Foundry. So, we can provide those. So do come and speak to us if you have any interest in those areas. So if that's all clear, let's now get into what the details of the device services, or how the device profiles are part of EdgeX. So a device profile can be thought of really as a template or a type or classification of a certain device. And in the main, it provides general characteristics for the types of the data that a device can send and what types of commands or actions can be sent to that device. So there's three main parts to this. So the first part is device information. How do you identify the device? And it's obviously things like a name, but also a description, manufacturer, model, and any labels you want to assign. And these are typically static variables, and they don't change. So once you have a device, once it's been created, it has a manufacturer. That manufacturer doesn't change. So this can be fairly static, consistent information. The second part is what we call device resources. And these are really the main things to be aware of here. This is the device characteristics or the data points that a device has. So in our thermostat example, we might be recording temperature and humidity, etc., and have a writable set point. So those are three device resources that you would have to model. And then finally, device commands, which is how we want to command the device to get and set values, particularly to get and set values at the same time, so we can control the way in which we do that. Now, device profile is described in a protocol-independent manner. So YAML or JSON are the two formats supported by EdgeX right now. And I like to think of device profiles and devices as being very similar to the way that, in programming speak in Java or C++, back in my old days as a programmer, you have classes and objects. So you write a class which defines what a thing can do, and then you instantiate it into an object at runtime, and that's your physical representation of that class. It's the same thing with device profiles and devices. So you can have a single device profile, and you could instantiate that 100 times. If you have 100 physical devices, you need 100 devices in EdgeX, but they can all use the same device profile. So what are the big picture steps, the high level here for onboarding a device? So there's 5 main steps. The first is that once you've written your device profile, and we'll certainly cover that shortly, you pass that to the Core Metadata service in EdgeX so that it knows the device content information that it needs to be aware of for interfacing with this device. Once you've done that, you then add a device entity to Core Metadata against a particular device profile. And the device is, as I said, it's the instantiation, it's the object, if you will, in our class and object, and in our class and object approach. And we provide things like the physical information, like the IP address, the port, the baud rate, those sort of things. How does the device service actually connect onto that physical device? Once that's happened, the Core Metadata service does a callback onto the device service to tell it that a device has been created, and this is how you access it. And at that point, the user can access or execute read and write commands to really get the data from that device. And finally, the device service events are published onto the internal EdgeX message bus, where they can be consumed by the interested subscribers. They might be EdgeX app services or the core data service or the supporting services and so on. So let's get to those three aspects that I spoke about. So the first is device information, and we sometimes call those device types. And this is, like I said, the identification information. And aside from the name, these fields aren't actually inspected at runtime by the device service. So we have the name, we have the description, a manufacturer, model, and a set of labels that can be used. So the EdgeX API provides a mechanism where you can filter device profiles against given labels. So it's a way to kind of look up and filter those device profiles. So there's an example on the screen there for example, an Elsner weather station, which can detect light and temperature levels. So we give it the model name, the manufacturer, and any labels we'd like to assign. So that's pretty straightforward. The next part is the device resources. And I said this is really the crux of what we have to do here. So these are the individual values or data points in our device. So the name and the properties section, this is where we ensure that the modeling is protocol independent. So if you look at that screen there, our the temperature field from our sensor, the properties, we have a value type of uint16, so it's an unsigned integer. It's a read-only device. We have read-write of value of R, and the units is degrees Celsius. So that is all protocol independent. It's only the attribute section where we really specify the details of our protocol. So in this Modbus example, we are dealing with things like, in the primary table of Modbus, you have things like input registers, holding registers, and coils. So this is where we specify that information and the address, how to look up the particular value in the Modbus device. There's also a flag called isHidden, which we'll cover more later. This relates to the automatic creation of core commands for this resource. And like I say, we'll talk about this later. Here is a table of some value fields for the properties. So the main ones we've already covered here. So the value type, this is clearly the type of our data, and we can support Booleans, integers, unsigned integers, floats, strings, binary objects, and arrays. We've got the read-write flag, which we've already mentioned. We've got the ability to set units, and then a few other settings that we won't cover now, but you can do little transformations as the data is collected. So some devices might need their data to be scaled by a certain value, or to be offset by a value, or to be masked or bit shifted, for example. All these things are able to be done by a simple configuration. And then we have the attributes value field. So like I said, this is protocol specific. This one for Modbus, we've got the primary table. Like I said, we've got holding registers, input registers, and so on. We've got the starting address. And then sometimes some Modbus devices need their data to be byte swapped or word swapped. So there's mechanisms to do this, to do with endianness and so on. We won't cover that now. And then the third part of the profile is the device commands. Now, these are optional, and these give control or potential control over accessing of multiple device resources at the same time. So either for logical or optimization reasons, maybe you've got data points that you want to treat or you want to collect at the same time because it makes more sense to do that. Maybe there's optimization regions where you don't want to make multiple calls onto the same device. If you can collect them at the same time, that's much more efficient. So you've got that capability with the device commands. And from a previous slide, I mentioned the device resources is hidden field. So if that's false, you automatically have a singular command generated for it that the core command service is able to invoke. This was an optimization we added when we refactored the device profiles for EdgeX version 2 just recently to make the profiles much more succinct. And people usually or often use device commands in conjunction with EdgeX auto events. So you may be aware that auto events are mechanisms that let you perform repeated periodic actions on a device. So if you have an auto event that every second, for example, tries to read the values, then you can get all those values on that second period and configure that in one go. And again, there's an is hidden flag for the device commands. This relates to the automatic creation of commands, again, from the core command service. So the default is false. So we won't hide those, so they are available. If you want to minimize the operations available, then you can set that field to true. Okay, so I'm going to run through a worked example, like I said at the start, and I'm going to focus on a Modbus power meter. So Modbus is, I'd still think, the most frequently used protocol that I see, certainly at EdgeX and at IoTech. So it's really important to have good Modbus support. So the device I'm going to use is a Modbus power meter. from a company called Dent Instruments. And there's the data sheets and the user manuals are linked there. So the user manual in particular, we're going to need, and I'll explain that in a second. So starting out, so what I'd like to do usually is to keep the syntax correct and keep things simple. I like to use an existing file, a base file. From that EdgeX provides. And there's one there that on the screen. So I'll do a wget where we can pull that file down, then we can edit it. It's a good way to start out. So in our case, as I said, for the identity information, we want to describe, or we want to define what we would like to, or how we'd like to identify this profile. So it's a name and description. It's pretty simple stuff. And reminder here that this metadata is not interpreted by EdgeX. So we're free to put whatever we like in these fields. So I'll just go ahead and do this now. So if I bring up my virtual machine, I'll just sign in. I've already got my terminal set up. So I will do that wget command to pull down that file. And I'll just rename it to, let's call it powermeter.yaml. So if I open it up, I just select to use Emacs. And what we're basically going to do is edit this file. So our name, we're going to set that to network meter, for example. Manufacturer, we can set as Dent Instruments, the model, PS3037, the labels. I said we can put anything here. Let's write Modbus, and the description we'll just write. This is just so we can identify it when we see the profile. Okay, that's pretty straightforward. So the next thing to do is, I'll go back to the slides. Think about the sensor values and the particular data points we want to acquire. And this is where we need the user manual. So the user manual will usually tell you the exact locations of each variable and what they do and how you should access them. And I'd always say keep it simple and model only the relevant attributes here. So some devices will have hundreds potentially of different data points that they can record. You don't need to necessarily have them all modeled if you're only planning to use a few of them. So I'd say keep it simple initially and model only the relevant attributes. And note also that in EdgeX 2.2 in Kamakura, we just added support to dynamically add and edit and delete device resources to a device profile on the fly. So you can always make changes to these device profiles once they have been created anyway. That's good to know. But for this example, this power meter example, we're going to focus on typical things you would see in a power meter. So the current, the power, the voltage, and the energy. But a couple of other interesting ones I found is there's a demand window size, which is measured in minutes. It's 15 minutes by default. And this is a configurable period of, or by which the meter should do its recording of its data. So under what period should it run averages? Under what period should it do its collection? So it's 15 minutes by default. And because that's configurable, it means the user can change that. So we're going to make that a read-write property, as you'll see shortly. And a similar thing for the line frequency. This is the frequency by which we do the collection. So 50 hertz or 60 hertz. Again, it's configurable. And these are going to be the device resources in our device profile. So if I, let's look at the current value for starters. So what I've done here is I've taken a screenshot of the user guide, particularly relating to this current. So you can see that Modbus register 40,009 relates to the current of all phases produced by the power meter. And a couple of things to note about Modbus. So holding registers start at address 40,000, and Modbus addressing for this device is zero-based. So what that actually means is that 40,009 equates to a Modbus starting address value of 8. And that's what we should configure in our device resource. So the user guide here has done us a favor because it's written that explicitly, but that's a good thing to know. And another thing is that we need to set I've highlighted here the key points, we need to set the value type. So this guide doesn't explicitly tell us, but we can infer that it's an unsigned 16-bit integer, because we can see that there is a following register that's occupied. So register 40,010 is occupied, so it means there's only a single word available for our current. So we can infer that it's an unsigned 16-bit integer, and that's how we configure that. So what I'll do is I'll go back to my file here, and we can just simply edit the existing one. Description, let's put average current. This is an unsigned integer in this case. And what I need to do here, I need to add specific protocol specific information. So attributes, primary, table, we set holding registers, and we set starting address to 8. And it's as simple as that, really. We just need to now go ahead and do that for the rest of the attributes we want to model. So the next one, this one's kind of more interesting, I guess, because it is spread over 2 registers. So the energy, it turns out, is modeled with a least significant word and a most significant word. So we've got 2 registers that we need to be concerned with. And well, we can read that as a float 32. We can read both words at the same time as a float 32. So we just model it like this. Starting address is 4,000 in this case. So it's 44,001 minus the 40,000 basis and the 1 because we're 0 based. And we get that. So I won't edit the file in front of you, but it's pretty clear what you have to do to make that happen. Okay, so the next step is to consider whether we want to access multiple values at the same time. Now, in our case, the data is largely in 2 categories with perhaps different requirements in terms of the data collection. So we've got the current, the power, the voltage, and the energy. Now, these are clearly the values. These are clearly regular periodic measurement data that we'd like to collect. And it's read-only. These are the values that we're collecting from our sensor. Whereas the demand window size and the line frequency, these are configuration values. They only occasionally change, and they're readable but also writable. So we need to model that in a different way. We can basically make 2 device commands to describe these 2 categories of information. So written up as part of a device profile, it would look something like this. So you just need to say, okay, the name, I'm calling these values, and it's read only. And you basically just list then the device resources that you want to collect as part of this values operation. Similar story for the configuration values, but we mark it as read write. Now note that the choice to group together these device resources in single commands allows the device service to potentially optimize accessing these device resources. Now that's implementation and protocol dependent, but potentially we can save bandwidth and processing power by invoking single commands to access all of those values at the same time, which can be a significant saving when you're trying to run at scale. So I'll explain more about that later on. To run the example, I'm working from home today, and so I don't have access to the physical device on my local network. But I can run a Modbus simulator programmed with the correct registers. So I like to use a graphical tool called Modbus PAL. And you can see here I've set up the power meter. I've set up all the addresses that we've mentioned with given values and I've named them, and I put binding automation, so that we've got, for example, here you can see on the screen, I've got the current as a linear progression, a linear step that we can model. So as the simulator runs, we'll get kind of sensible values in our registers. So it's good to test with. So this is the commands I'm going to run in a second. So the first command is to run a device profile upload file operation, and you just pass core metadata the file that we just created, and then you run the device command to basically create a new device. And I've highlighted here the important fields. So we've got the profile name that's part of our power meter, and then we've got the 2 auto events, like I said, for configuration. So I'm going to say, let's access the configuration command every 60 seconds, and let's access the values every 5 seconds. So this is really putting those device commands into practice. And a couple of other quick tips. I've used the EdgeX Compose builder to specify that I want Modbus, the Modbus service to be running as part of my Docker Compose. And it's always a good idea to, when you're working with YAML, to verify that the YAML file is valid. So there's various linter tools. You can run YAML int is a good one. You just upload the file or copy it, paste it into the browser, and it'll tell you that the file is valid, or it'll tell you the line number where there's a mistake if there is one. So let's go back to my terminal, and what I'll do actually, rather than edit that file, like I said, in front of everybody, I'm going to cheat a little bit. As we say in the UK, here's one I made earlier. So I'm going to overwrite that parameter file with one that I know to be correct. And this is what the file looks like. So it's all the things we spoke about: the current, the energy, the power, the voltage, and then our device commands. And like I said at the start, I'll make this file available on the EdgeX wiki page. So what we need to do, let's run up EdgeX. We do the Docker Compose up. Like this. Oh, I should show you my got Modbus PAL running here. And there's the values that I mentioned before. And what I can do, the first thing to do is to run that curl command to upload the profile, which succeeded. And then the next thing is to run the big curl command that onboards our device. Okay, good. So there's a couple of things I can do. Or you can see, first of all, that the simulator goes green when it's accessed. So every 5 seconds, we'll get a green ping because there's been an access of the data from that. If I go over to the EdgeX UI, which runs at port 40,000 by default, 4,000, sorry, we can take a look at the profile in the device. So we can see our device profile is online. These are the fields that we configured. We can look at the device. We can look at the commands that are available in our device. So we had 3 commands. So for example, I can get let's get the 4 values, and they're in raw JSON format. So there's our current, our energy, and power and voltage. So we've got the data collected. We can also just use the command line. So what I can do is show you well, there's a very simple way to get for example, the current, like this. And again, I'll make these commands available on the wiki page. So the value here was 20. Let me quickly show you the configuration. So remember, the configuration was read-write, which means we can set the values. So if you look here at the demand window size is currently 15 and the line frequency is 50. I can change those 2 values by running a command like this, setting the configuration, and we've got the two values with the two properties with their values like this. So we can look at the demand window size, and you can see that it's actually changed to 20 just now, and the line frequency is 60, which is good. So we've successfully modeled the read-write capability of our devices, and we're accessing those data points at sensible periods, because we've got one accessing by default every 5 seconds, the data values, and the configuration values only every minute, to try to minimize the load on the device. Okay, that's good. Hope that all makes sense. Let me step back to the slides for a second, and I'm going to now quickly talk about some tooling to make this even easier. You might have noticed that working with YAML or even JSON can be a little bit fiddly. It is quite easy to make a mistake, and it also requires quite specific knowledge of the syntax and the things you're modeling. It's easy to have typos and copy-paste errors and stuff like that. So, at EdgeX, we're certainly, as I said earlier, keen on usability and making things really easy for the user. So tooling is really helpful here. So you can really benefit and simplify the work involved, which ends up saving time and money. You can eliminate typos and syntactic errors, but probably most importantly, you can abstract away the real details of YAML and JSON formatting and instead provide an intuitive GUI. And that means that the software is no longer just for engineers. So we're quite aware that people perhaps that roll out EdgeX-based systems aren't necessarily right into the details of all the coding. So to provide much high-level tooling is a really positive step, I think, and makes EdgeX systems configurable to many more people. So we've got this, we call it the device configuration tool, DCT, and it's a commercial EdgeX tool that we provide to our customers, but we've also decided to make it free for EdgeX users. So you can go ahead and sign up at dct.edgexsys.com. Like I say, it's free, and you'll find that you should find that you save time in creating and editing and maintaining these device resources. You get graphical views and context-aware menus for modeling these devices to make it much more pleasurable, hopefully, than editing raw files. So I'll do a quick demo, but just briefly cover the steps involved. So we have the device types. First of all, this is the device information. So you create a new device type, you choose the protocol, and you'll see if you're an EdgeX user, you'll see the standard ones that we provide support for the EdgeX Foundry. EdgeX customers will have the full list. But you basically create a device type, and you get a menu like this, which is all the same fields we spoke about earlier, the description, the manufacturer, the labels, and so on. Easy to edit that and save. And then you go ahead and create your device resources. So for each device type, you add a new device resource. So these are protocol specific, like I've been saying. So if you're creating a Modbus device resource, then you'll see a Modbus attributes menu. So the holding registers and all that stuff that I mentioned earlier will be available, and it's drop-down list based and that sort of stuff. So, much harder to misconfigure than just editing a raw file. And then the third step is to create a device profile, a final file out of this. So this is where you basically pick an existing device type, you create a name for your profile, noting that a single device type can have multiple device profiles, like you might want to have different combinations of device resources that you want to expose for a particular device. So you can model it like that. And then you basically select which device resources you want to have in this particular profile. And again, we've got menus where you can just click or select all even to really make this straightforward. And then finally, you model any device commands you want. So this is where you set the operations you want to invoke at the same time. So again, menus that you can simply click to choose the ones you want to be set at the same time. So I hope you see that that's much easier and cleaner than editing a file. What I'll quickly do is show you that actually. So I've already got that I'll quickly sign into DCT, put it on my desktop like this. So if I sign in, we'll see where if I find it, the network power meter for let's filter on Modbus, the network power meter. So here's all the information or in fact I can edit it as well if I wanted to add another label. Easy to do. Device resources power meter, we can just list device resources, and again we can edit these if we wanted to. That's the context specific information I spoke about. And then you can create a device profile. So I'll quickly create a new one actually. So I'll create power meter 2, a quick example, and you select the device resources. Let's say we want all of them. And then you select the device commands. Let's say in this case, I want to read the current and the line frequency at the same time. So you can specify that. Okay. And then you just go ahead and export in it to whatever format you like. So we support YAML, V1 and Metadata EdgeX version 1, version 2 formats, JSON as well. We also support other formats. So for example, the Microsoft Digital Twin Definition Language notation is supported by this tool as well. So this tool is aimed at really being quite a high-level mechanism to model your edge devices and then export. In fact, our commercial version supports AWS site-wise as another asset model. Okay, so if I jump back to the slides, again, a couple of other time-saving features that make things easier here. You can import your existing device profiles into the DCT, and then they're modeled in that independent way. And then you can export them back out again as different formats. So V1 or V2, like I said. So that's really useful. That, in fact, the EdgeX community will be using that for migrating or updating between version 1 and version 2 profiles. You can export in other formats, like I said. And another feature that's nice is that you can import device resources in CSV file format. Often, whilst the tool can be really helpful in mitigating errors, you still sometimes have to, if you have a lot of them, you've still got to sit there and spend quite a lot of time creating these profiles. Some device manufacturers can provide this information in a more structured format. So for example, a CSV file or another script, you could write a simple script that would generate a CSV file format, for example, for your device, and then import those device resources en masse, and then they're available. So again, if I quickly jump back to the demo, I can import, for example, I've got a file here, a list of mods. Let's switch device I want to before. So it imports these, just in this case 3, but it could be an arbitrarily long list of resources together with their names, units, Modbus settings, and so on. So we import that, and now they're available in our power meter to be selected and be used as part of our device profile creation steps. So it's another good tip to save some time. Okay, I'm going to quickly touch on the EdgeX Ready program. So the EdgeX Ready program highlights the ability of EdgeX users and adopters to work successfully with EdgeX. And it's a self-assessment process that requires an adopter to basically get and run an instance of EdgeX and create, validate, and onboard a set of device profiles and devices into the system. So the DCT really helps here in the validation of these device profiles. First of all, it provides syntax checking. So you can import, like I said, profiles into the tool, and then you can verify and export them out and verify that the profiles are correct and valid. So to join the program, you basically submit your materials as a participation form, a set of device profiles that you validated, and some sample sensor data that's proof that you've got data sent into the EdgeX platform, and you send those to the certification group, and you can get the EdgeX Ready badge, which is nice. All the details are on that wiki page again. And then just before we wrap up, a couple of other points to help here. So going further, more assistance if you need it. So I mentioned my company iTech and the EdgeXpert product already. One thing we do with EdgeXpert is provide commercial device connectivity for EdgeX. So for the built-in or the EdgeX provided services like Modbus and BACnet and REST and MQTT, we provide enhanced, productized and ruggedized versions of those services that are kind of just ready to be used in deployment. But a whole set of other device service connectors that aren't available in open source, for example, interfacing with EtherCAT devices, interfacing and getting data from Siemens PLCs. There's a whole range of them there. And these can be used both against the regular EdgeX platform, or they can be used in conjunction with the full EdgeXpert platform. That's up to you. But let us know if you have any questions in these areas, and we'll try and help you out. I wanted to quickly say about Modbus. So particularly coming back to our device profiles, the value add service of Modbus that we provide, I've highlighted in yellow there, we support the multi-read and write operations for the faster data access. So those device commands, if you remember, where we group the device resources together, our Modbus implementation, which we've rewritten in C to make it even lighter and faster, can support multi-reads and multi-writes, which can really help reduce the number of Modbus requests going across the network. So that's the Modbus. And BACnet is an interesting one as well. So I touched on automatic discovery once or twice in this talk. And you'll see that for all of the examples we've done so far, you have to create a device profile, whether it's by hand or via the tool or via the use of scripting, you still have to create a device profile. There's some protocols, the smart protocols in particular, like BACnet, and OPCOA is another one, and Bluetooth is another one. These help you out a little bit, and they can provide you automatic discovery capabilities. So some of the iTech connectors can actually scan the network and automatically generate device profiles on the fly, and even do the onboarding of devices with a few controls as to how that should be done. So that goes a whole step further and really makes things easy to use. BACnet as well supports multi-read and write operations, as well as some extra operations and types and objects that you would define in those device profiles. So again, let me know if you have any questions on these areas. So I'm going to quickly point back at some resources. So the docs here are pretty good for device profiles. There's a good walkthrough in using Modbus. I've adapted a little bit for my example, but there's some really good information on there. The device configuration tool, as a reminder, is free for EdgeX users. Please go ahead and sign up and use that. I think it's a really useful tool for EdgeX developers. And let us know any questions on the Slack channels, particularly the device services channel is most relevant here. And we've got a load of YouTube and social media places to come and join us. So that's great. So that is the fourth talk pretty much completed now. Like I said, next week, come back and join the Canonical team for a discussion about getting started with snaps. And that takes me to the final slide. So just to thank everybody for their attendance. Please let us know how we did, or if there's any other topics you'd like to see. We're very much open to continuing to run these tech talks. Contact us on those email addresses, or contact me directly if you like. And I'll open the floor to any questions. I did see a question already come in on the forum while I was talking. I think Lenny's actually already answered that question. Yeah, so the question was, I see the parameters profiling or modeling as, let's say, scalar values. Is there a way to define arrays or tables, e.g. temperature multiple points, or is this a protocol specific way? And Lenny's answered by saying EdgeX has array tables for all primitive types. Yeah, that's right. So then you posted the link there. So thanks for that, Lenny. Okay, any more questions? So just a reminder that all this material will be posted online on the wiki page. I'm sure there'll be a YouTube video as well that comes out of it. And I'll certainly stay tuned for any more feedback that you have on these email addresses. Okay, so well, no more questions. That's fine. And just leaves me to say thanks again for your attendance and look forward to speaking again soon. Thanks, everyone.